This series of instructional videos is intended to cover some of the basic principles involved in computerized motion control. Breaking down the process of motion control into a few clearly defined functional units and demonstrating how these units interact not only eases understanding, but also provides a model which a technician can use to simplify his designs and make them more maintainable. Some of the same principles that are explained here can be applied to implementing servo motors, but alternatively, stepper motor technology will be used in this series due to its simplicity, economy, and reliability. Stepper motors are powered by a special type of device called a translator. Most translators function very similarly. When activated by an electronic signal, or pulse, the translator moves the motor shaft by a small, incremental amount. A second signal, called the direction signal, determines whether the pulse moves the motor shaft clockwise or counterclockwise. This is described more thoroughly in the next video, entitled The Stepper Motor and Translator. For each signal that it receives, the translator only has the capability to rotate the motor's shaft from its current position to its next adjacent position. However, input signals provided to the translator in timed succession are used to accomplish more complex motion. The functional unit that provides these signals to the translator is called the indexer. Ability Systems Indexer LPT software uses an IBM-compatible PC to generate translator-compatible control signals from the standard parallel output port connector. The parallel port is ideally suitable for controlling motors due to the multiple outputs that are physically available. These multiple outputs can be simultaneously manipulated by the software, enabling Indexer LPT to control up to 7 motors together across complex patterns. Computers can be outfitted with multiple parallel ports by means of plug-in adapter cards. Parallel port adapter cards are rugged, inexpensive, widely used, and readily available. Standard mass production of these devices simplify troubleshooting and make machines more maintainable. Indexers receive commands and also interact with electronic signals in the control system. Indexer LPT's plain English command set is designed to give the machine designer and technician close control over the machine. Using the diagnostic screen provided with the program, here an Indexer LPT command is being used to generate 2,000 electronic pulses. The translator portion of the system responds to each pulse, moving the stepper motor shaft 2,000 incremental steps. While useful in exercising close control over the machine for the technician, Indexer commands may not be convenient to a machine operator. For example, Indexer LPT's move command, just shown in this demo, is useful for the technician to use for experimentation, design, and troubleshooting, but it is much more suitable in certain settings for an operator to direct machine motion in more familiar units, like inches or centimeters. Among other things, the application program accomplishes this purpose. Using the indexer to generate pulses, the technician can experimentally determine exactly how far a linear stage moves for a given number of pulses. The application program, here the Ability Systems G-code controller program, accepts this information as part of its configuration. To move the Y stage of our demo machine by 1 inch, 5,080 pulses are required, as shown here in this setup dialog. This clip shows how a G-code script, with dimensions called out in inches, can generate a tool path that would cut a 4-inch diameter circle using a 1/2 inch diameter circular cutting tool. The application program calculates the straight line paths that are required, communicating these approximating line segments to the indexer. Indexer LPT assembles these paths end to end and smoothly generates the electronic pulses that move the machine over the desired path. Between the actions of dropping and retracting the stylus, you can hear the pitch of the control signals change as the motors accelerate over the circular path, traversing from one segment to the next, then decelerating to a stop. Simple shapes like this circle are easy to script by hand in a text editor like Notepad. Even panels, like this, are relatively simple to hand code. More complex paths, like this, are more suitably scripted from CAD/CAM software that is designed for 3D modeling, such as BobCAD, SignLab, Mastercam, Visual Mill, etc. So in this case, the CAD/CAM software generates the scripts. The application program interprets the scripts into indexer commands and transparently uses these commands to interact with the indexer. The indexer, in turn, directs the translator with appropriately timed control signals. Though Ability Systems G-code controller is very versatile and can be configured to accommodate a variety of different types of machines, there are applications that are specialized to the extent that a custom application program is needed. In these cases, Indexer LPT's simplified programmer's interface and thorough documentation open the possibility of writing your own application program using a standard programming language such as BASIC, C, or Delphi. Here is a telescope lens grinding machine which is controlled by an application program written in Fortran. You can check out the pictures section at abilitysystems.com for other examples. Now that we have summarized Ability Systems' approach to computerized motion control and discussed automation ranging from defining toolpaths using CAD/CAM to the actual signals used for controlling the motors that move the machine, I hope you'll enjoy the following sessions which more comprehensively explore and explain each of these categories in more detail.